C1, Quadratics, Example 33. So in this question, I have one linear and one quadratic simultaneous equation. So I'm going to rewrite them out and I'm going to give them labels. So my 3x plus y equals 8 will become my equation number 1. And my 3x squared plus y squared equals 28 will become my equation number 2. Now I'm going to rearrange my linear equation, which is my first equation, and this will give me y equals 8 minus 3x, and I'm going to give this the label 3, so that now I can substitute what I've got for my equation 3 into my second equation to eliminate all the y's. So this will become 3x squared plus, now instead of where I've got my y squared, I'm going to substitute in what I've found here. So that'll be 8 minus 3x all squared equals 28. So expanding out these brackets, I still have my 3x squared, but now I have plus 64 minus 48x plus 9x squared equals 28. So gathering my x squareds together and bringing my 28 over to this side will give me 12x squared minus 48x plus 36. And that will now be equal to 0. So all of these terms divide by 12, so I'm going to divide it through by 12, which will give me x squared minus 4x plus 3 equals 0. And now I'm going to factorize this. So that will give me x minus 3 and x minus 1 equals 0. So that means that either my x minus 3 equals 0 or my x minus 1 equals 0, which gives me the two x values, x equals 3 or x equals 1. So I found my x values for the points where these two lines intersect, but now I need to find the y values that accompany them. So using this first one, so when x equals 3, substituting it into my first equation, that'll give me 3 times 3 plus y equals 8, which is 9, which means that 9 plus y equals 8, so y equals minus 1. And again, now using my x equals 1, so when x equals 1, we have 3 lots of 1 plus y equals 8, and that means that 3 plus y equals 8, so y equals 5. So I've got my two x values and my two y values, but again, it's best to write it as coordinates. So we have 2 points of intersection and these are 3, minus 1 and 1, 5.